in Lesson 5, we're going to look at how to sketch polynomials. So instead of just looking at quadratics, we're going to extend this and look at higher powered polynomials. So one thing that we have to talk about is whenever we have repeated zeros, so meaning x equals 2 is repeated, it's a solution 2 or more times. So basically, what we call this is a multiplicity. So the multiplicity of a zero just means the number of times the zero occurs. So for example, if I have the polynomial y equals x minus 3 squared, this means that I have a repeated 0. X minus 3 is a factor that occurs twice. So since I have this exponent here, if I were to go to find the 0, so set this equal to 0, so you square root both sides, we get x minus 3 equals plus or minus 0, which is just 0. So we get x equals 3. This x equals 3, since it came from something with an exponent greater than 1, means that this 3 is the repeated solution. So basically it means that x equals 3 has multiplicity of 2. So this has multiplicity of 2. So then how this will be helpful when we're graphing or when we're sketching polynomials, because remember, we're not going to be using a calculator to do this. This is all by hand. So you have to know what that multiplicity and how it's helpful. What does that actually mean? So if we have odd multiplicities, so anytime we have 1, 3, 5, 7 as an exponent, so the zeros occurring that number of times, that means that your graph is going to cross the x-axis at that point. So it's going to pass through the x-axis. If it's even multiplicity, that means at that 0 or at that x value, your graph will not cross, which really means that your graph is going to be tangent at that point. So it's basically going to like bounce down and then go back up, or vice versa. So it's going to be tangent. So let's actually look at how that all works out. So let's look at an example. We're given this function here, and the first thing we want to do is we want to do the leading coefficient test. So we have to decide, well, what degree, first of all, is this polynomial? So the degree of this polynomial, you look at your exponents. Now we haven't seen them in this form yet. We've seen them all in the form where it's adding and subtracting between each term. So really you have to think about this as this part is going to be a degree 3 polynomial. This part's going to be a degree 2. But when you multiply, let's just say, I'm just going to put z here, z to the third times z to the second, so a degree 3 times a degree 2, you end up with a degree 5. Because remember, you add the exponents. So that's just to kind of show you, I would add these, and my degree is actually going to be 5. And then the leading coefficient is just the leading coefficient of all of these, which is just a 1. So that means I have an odd degree and a positive leading coefficient. So that tells me my general shape of my graph has to start down here and end up here. So it's going to look something like that is basically what we know in terms of the ends. We don't really know what's happening in here yet. That's why we have to do these other steps. We have to figure out what's happening in here by first figuring out the zeros. We don't know how many times it's actually going to cross the x-axis, because remember, you could have complex zeros and you're not going to see those. So let's find the zeros. So to find the zeros, this is where you're going to set your polynomial equal to 0. which essentially just means take each piece, so I can split it. And cube rooting both sides here, square rooting both sides here, you're going to get 0 when you cube root 0 and square root 0. So basically you can kind of just forget about those exponents here at this stage because it's not going to change anything. So remember, those exponents really tell us about the multiplicity. They don't really tell us, they're not going to really do anything if you just kind of avoid them or forget about them at this step. So we get our two zeros, we get -2, and we get x equals 1. So since this is a degree 5 polynomial, remember we should be getting 5 solutions, where some of them could be imaginary and some of them could be real, which in this case, right now, I only have 2 solutions, but that's where the multiplicity comes into play. So since this is x equals 1, but it came from degree 2, that means this occurs twice. It also means because it's degree 2, we're going to be tangent. It's an even degree, so your graph's going to be tangent through x equals 1 or at x equals 1. And then x equals -2, that actually gets counted 3 times. It's a repeated 0 3 times. So we still get our 5 solutions. 3 of these, 2 of these. So it still works for that whole fundamental theorem of algebra. So I'm going to, over here, I'm just going to just sketch these points. So I have -2 and I have 1 so far. So let me go ahead and just plot those. Those are going to be important points. And remember, I know my graph is going to start down here. It's going to pass through this. And it's also going to pass through this, or it's going to at least touch it. We don't know. We haven't talked about the multiplicity completely yet. So let's look at that next to decide, is my graph going to go through or is it going to be tangent? So at x equals 2, or x equals -2, the multiplicity is 3. So since it's odd, that means it crosses at the x-axis. Then we look at x equals 1, and since the multiplicity of that one is 2, the graph is tangent at the x-axis. So since this was even, the graph is going to be tangent. So that means I know I'm going to have my graph going through this -2, and it's either going to be tangent so that it opens downward or upward at this point. So then the last thing is to be able to understand what's happening up here. So does this just go up and then down and then come back through? We have to look at the y-intercept. The y-intercept is always an easy point that you can figure out. Remember that if your polynomial is in standard form, like ax to the 5th plus bx to the 4th, where it's addition and subtraction between the terms, the constant is the y-intercept. But the other way to find the y-intercept is to set x equal to 0. So basically what I'm going to do here is I'm going to take and I'm just going to plug in 0 wherever I saw an x. So I just, into that original equation, I'm just plugging in a 0. So we get 8 for the first one, 2 to the third is 8, times 1 here is going to give me 8. So that means my y-intercept, so if I go back to my graph, I go up to 8. So here's all my key points. I'm going to label these x and y. And remember, this is just a sketch. It's not going to be perfect, but we basically come up with these key features that give us enough points to be able to plot this. So we know that our graph has to start down here because remember the general shape of the ends. That's where they need to end up. So it's going to start down here. It's going to pass through -2. It's got to come up to this point. It's going to come back down and be tangent at 1 so that it can end where we said it would end. So it's just gonna, this is a general sketch. Okay, so this kind of gives us a rough idea. But that's the best we can do without having a calculator. Now, if you wanted to be more accurate, you can pick some other points. So if I take like -1 and plug it in, I could be more accurate over here and find some points. I could plug in, 2, 3, 4, 5 for x, figure out some more accurate points. So that's always an option, but the main points that you have to plot are the ones that we just did. You got to do the leading coefficient test to see what the ends are doing. You got to find the zeros so that you know if it's where it's gonna, what it's doing in here basically. Because if you look at my first sketch, I had my ends. I knew what my ends were doing, but I didn't know what was happening in this section. So that's why we got to have the zeros. And then the y-intercept is another important piece because it kind of gives us that other point where I know, okay, am I just going up and then coming down here somewhere to cross through this or to be tangent? So you kind of have to use those y-intercepts and x-intercepts for that. And then the multiplicity is huge because otherwise I wouldn't know if this had to be tangent here or if it passes through. Like that really helps you determine those other little details. So let's just look at a couple more of these. So again, this notation f of x you've seen, but this is really just y equals. You can think of it that way. So this polynomial is in standard form. So it's pluses and minuses between the terms. Well, in this case, just minuses. So it's also in decreasing order. So this one's a little bit easier, I think, to use a leading coefficient test on. So the degree of this is 3. That's the highest exponent. The leading coefficient is 1. So again, it's positive and odd degree. It's going to follow that same end behavior as the last graph. So it's going to look something like this. And then to find the zeros, we'll take your equation and set it equal to 0. So in this case, it's not already factored, so we have to factor. So let's start by taking out an x. So we have x squared minus x minus 6 left. And then it looks like we'll be able to do quadratic factoring. So we have plus minus x minus 3, x plus 2 is going to work to be able to add to -1. Now you have your 3 pieces here, so we can set each piece equal to 0. And solve for x. So we get x equals 0, x equals -2, x equals +3. All of these have multiplicity, notice, of 1. So since I didn't, like right here, these are all degree 1, right? There's an exponent of 1. Also, if you look at your degree, my degree of the entire polynomial is 3, so I can only have 3 solutions. So I have 3 separate solutions, so that means I don't have multiplicity other than 1 for each of these. So we can go ahead and we can plot those points. So I have 0, -2, and 3. And remember, I know what my ends are going to be doing. So I'm just going to add this about the multiplicity. We already talked about it. But all of these have multiplicity of 1. So x equals 0, x equals -2, x equals 3. The multiplicity is 1. So your graph is going to cross. It's going to cross the x-axis. So the last thing that's going to be important here is the y-intercept. And remember, the y-intercept is the constant. So since this has already been multiplied out, the constant is just +0. There's nothing added at the end. So that tells me that my y-intercept is just going to be 0. So y is equal to 0. Or remember, you can write this as a coordinate. So we just use the constant for this. So again, plot that, but we already have that point. So what's going to happen for this one, you're going to start down here. You're going to cross. You're going to cross again. And then you're going to cross again. Because remember, the ends have to start down here and end up here. So the only way to get from here to there and go through these 3 points is to go the way I went. Now, I don't know how high up this is. I don't know how low this is, so we're not going to worry about that. If you wanted to figure it out, you could do like what we did for the parabolas. Figure out halfway between these and then plug in. Figure out halfway between these, plug in. That would give you more accurate, but for right now, I just want you guys to be able to get the general sketch. I'm not too worried about all the little details. So let's look at one last example. So we have a degree 4 polynomial. So first thing, leading coefficient test, figure out what those ends are doing. So the degree is 4. Leading coefficient is 1. So since it's an even degree, the ends have to be doing the same thing. And in this case, the ends are both going to be going up because it was positive. So this is what we know has to happen for our ends. Both of them have to go up. To find the zeros, you're going to set it equal to 0. And here, we can't factor out a GCF, but if you notice, this is in that quadratic form. It's just like me having an x squared, an x, and then the number. The only difference here is because this is an x to the 4th, when we split up our x's, instead of just doing x and x, I have to do x to the 2nd. So I can still look at this as add to -1, multiply to -12. So it's going to be plus minus, opposite signs as we're multiplying to a negative. Bigger number is going to be negative. Smaller number will be positive. So when we add them, we get -1. And then if you look, this I can't break down, but I can break down this other piece here. I have a difference of perfect squares. So I go ahead and I break that down. So square root each piece, opposite signs. Now we have 3 sets here. We're going to set them equal to 0. So x squared plus 3 equals 0. X plus 2 equals 0. X minus 2 equals 0. And remember, it's a degree 4, so I should be getting out 4 solutions. So x squared equals -3. When I square root both sides, you should be getting out 2 solutions because it's a x squared. So it's going to be plus or minus, and I'm going to have an I here because I had a negative underneath the square root. So I square root of 3. Here I'm going to have x equals -2. Here I'm going to have x equals 2. Now remember, the number of zeros always equals the degree, but the number of x-intercepts is at most the degree. So in this case, this solution or these 2 solutions are not x-intercepts because they're imaginary numbers. So these are not x-intercepts. You can't actually go on your graph in the real number system and plot those. However, these 2 are, so I can go ahead and plot that. And I'm going to label my axes. And then I'm going to look at the multiplicity. So again, as these are all multiplicity 1, because remember you need 4 solutions if it's a degree 4. I didn't have any exponents here other than 1, so that's how I know that each of these occurred only one time. So the multiplicity is 1. So that means your graph crosses the x-axis for each of these. And then the last thing that we need to look at before we actually go and sketch this is the y-intercept. Y-intercept, remember, is always the constant. So we look at the constant, and in this case, the constant is -12. So that means my y-intercept is -12. So we're going to go ahead, 1, 2, so go ahead and count out to -12. I'm just going to extend this graph down. And then we can plot our points. So basically what this is going to look like, we're going to start up here. We're going to cross through negative 2. We're going to go down to negative 12. And we're going to come back up through positive 2. And that's going to be the sketch. So it almost looks like a quadratic because remember, we still have those 4 zeros, but 2 of them are imaginary. That's why we're not worrying about seeing those on the graph.